we've talked about probability distributions. We talked about how to find the mean and variance and graphing and standard deviation of any kind of probability distribution. We've also talked about the binomial experiment. And what this is going to do is going to kind of combine those. If you happen to know you have a binomial experiment, can you actually write the distribution, find the mean, the variance, standard deviation, and actually graph it? And the answer, of course, is yes, because you just did it. You just did this in the other things. You already know how to do these, and it's just making sure you know how to calculate those. So we're going to use RStudio to calculate things for us. We need to first calculate our binomial distribution values. So we're going to go back into RStudio. I need to put in my X values. So let's go look at my example real fast. My example is according to an article in the American Heart Association's publication, Circulation, 24% of patients who had been hospitalized for an acute myocardial infarction did not fill their cardiac medication by the 7th day of being discharged. Suppose there are 12 people who have been hospitalized for an acute myocardial infarction. And what I would like to do is write the probability distribution for the number of people who did not fill their medication. So as a reminder, that means X is equal to the number of people who did not fill their medication, their cardiac medication. All right, so that's who we have. And so we want to write this probability distribution. It helps to know what my N is. My N, there were 12, so my N is 12. It helps to know what my P is. My P is 0.24. All right, so I want to actually come up with the probability distribution for this. And so we're going to go and use RStudio for this because we're not going to calculate these by hand. The first thing I'm going to need is I'm going to need those X values put in there. So I need my X values. My X values are going to be, again, put this little arrow to say everything after this little arrow goes into the X variable. We're going to combine, and we're going to combine the numbers 0 to 12. Then the next thing is we got to calculate those probabilities, those binomial probabilities for each one of these. This was a binomial distribution. We have to go calculate those. The way we calculate those is with dbinom, would calculate for each individual value. But I also need to save them. So I'm going to call it P for probability. And we're going to do the dbinom. And then we want to do it for every single one of the values that R can take on. And so we want to do 0:12 to say for all of them. For every single value, you're going to calculate this. And this can take on all the values from 0 to 12. And then you're going to put in your N value and then your P value. And then that's it. And you can hit enter. And notice again, it didn't do anything, but over here, it put those values in there for you. If you want to see those values, you can just type P and it'll actually calculate those values for you. You can also type X and it'll give you those values. So we actually have our P values and our X values. We can copy and put those into where we're working. It would be better to put into a nice table. I'm going to be a little lazy right now and not put into a nice table, but it would be better to put these into a nice table, put your X values, put your probability values that go with them into a really nice table, and just to organize things. But we're going to go ahead and graph it. And the reason I save these in RStudio is so I could graph easily. So again, you do need to have packages on. You need to have the ARM package on. So at the very top, because they're in alphabetical order, so make sure in alphabetical order that the ARM package is on. So ARM is on, that just means there's a little checkbox there. The checkbox is checked. And then you also need the weighted .desc.stat. That one also needs to be turned on. And again, they're in alphabetical order, so it's all the way down here. You don't see all of it, but there it is. If you just hover over it, it'll give you the name. So those are now both on. And now I can do this. I'm going to go ahead and do a discrete histogram. So remember, it's discrete. Just start typing discrete, and it'll show up as their list. Arrow down to it, hit the tab button, and it'll put it in there for you. And then we want our X and our P. You could have called these, by the way, anything you wanted. You didn't need to use X and P. You could have used number, patients, whatever you wanted to call it. And there's my histogram. As a reminder, we do need to change this just a little bit. We're going to go ahead and put a comma and say we want to have the bar width equal to 1. So the bars actually touch. And then you should probably have a title. And unfortunately, this one, the title is called main. And so your main would be number of people who didn't fill medication. And there's your nice little histogram. And again, I can copy this command and put it into what I'm working on. And then I can also, and I'm going to go ahead and move this just a little bit so I have a little bit of space here. I can also go here and type in my graph. So again, if you're using an RMD file, you don't need to do this. If you're using a Word file, you need to do this. Go over here to your graph. You say you want to export it. We're going to copy to clipboard, and then either right click and copy it, or if you're on a Mac, you have to do the control click to get a right click. And then we can go ahead and post this in wherever you happen to be. And there it is. And looking at this, looks like it's skewed to the right. Because remember, the short stuff is where it's skewed. So we can now say that this is skewed right. When that tells me that most people don't fill the medication, and that's not good. We want people to do that. So most likely we need to do some research and some education to show people why they need to do this. We can also find the mean, variance, and standard deviation for this. Again, the same thing we've done before. For this, we would do, the mean would be w.mean. Again, this is not using the ds.stat. This is slightly different, or df.stat. This is slightly different program, different process for this one, for probability distributions. And then you type in your x comma p. You do w.var for variance, x comma p, and then you do w.sd for standard deviation, x comma p. And so there's your mean, your variance, and your standard deviation. And so again, what this tells me is that on average, 0.3 people fill the medication. So again, that's not good. The variance is only about 0.5. So we're really looking at, the standard deviation is about 0.5, the variance is about 0.3. And so we're looking at 2 standard deviations away would be, it wouldn't be very unusual for even 3 people not to fill their medication, or 3 or more people. So you really probably need to do some education and explain why it's important to do this.